Well, there's more of a disruption than I thought. The camera stopped working. Turns out to have been a loose USB connection. And I could have fixed that without stopping the video, but I was not thinking clearly. So anyhow, we got a second video. This video picks up on the last one we did, just to review where we're at. Okay, we have divided the expression x minus 2 into the expression 2x squared minus 2x cubed minus 5x squared plus 7x plus c. We've gone through all the steps of doing that long division, and we got a quotient 2x squared minus x plus 5 plus c minus 10 over x minus 2. We then multiplied the divisor by the quotient, which should give us the dividend, the thing under the division sign. So we've done that here. We used the distributive law. We did it step by step. There was a step of factoring where we had to factor out the c minus 10 over x minus 2 from two terms, giving us the result that we have gone over in some detail. Okay? And then noting that the expression x minus 2 multiplied by c minus 10 over x minus 2 just gives us c minus 10. We finally simplify the product and we get something that I know isn't right. So now we go back and find the error. And if you haven't already done so, stop and look for the error that I made. I made one simple error, very common error. Okay, hopefully you had time to look for the error, locate it. Very simple. Notice that I had a little plus on this 10 here, indicating that my constant number c, we're going to subtract negative 10 from c, meaning we're going to add 10 to c. And I carelessly wrote down c minus 10 without thinking clearly about what I was doing. That should have been c plus 10, which means that our last term should have been c plus 10, not c minus 10. So all the c minus 10s that we have in all these expressions have to be changed to c plus 10. Fortunately, it's a very easy error once we spot it to correct. So every time we see c minus 10 over x minus 2, we make it into c plus 10 over x minus 2. Now, when we get down to the step, we multiply x minus 2 by c plus 10 over x minus 2. The result is going to be c plus 10, not c minus 10. And now we see that the minus 10 and the plus 10 give us 0. We no longer have a minus 20. And now our product is the same as the dividend. Okay. We're dividing x minus 2 into 2x cubed minus 5x squared plus 7x plus c. And now we've shown that the divisor x minus 2 times the quotient 2x squared minus x plus 5 plus c plus 10 over x minus 2 does give us the dividend, 2x cubed minus 5x squared plus 7x plus c, perfectly matches what we have under the division sign. Okay. Now, I said that you were welcome to let c be any number you wanted. So if you'd let c equal 7, then the quotient would be 2x squared minus x plus 5 plus 7 plus 10 over x minus 2. So it shows c equals 7, the quotient. would have been 2x squared minus x plus 5 plus 7 plus 10 over x minus 2, which would just be 2x squared minus x plus 5 plus 17 over x minus 2. So if you don't believe me, just go ahead and replace c by 7 in the original division. Do all the steps. Well, all the steps are going to come out exactly the same as before, except for the last step. And if c is 7, you would have then 7 plus 10 is 17, and that would be your remainder. So you'd put your remainder over your divisor. Okay. Now, this isn't a polynomial. Why? Because 17 over x minus 2 is not a multiple of a non-negative power of x. You got the second power, you got the first power. 5 is just 5 times the 0 power. X to the 0 is 1, so this is 5 times x to the 0. This is not something times x to any power. So this is not a polynomial. Since 17 over x minus 2 isn't a multiple of the power of x. Now, how could we get, is there a value of c that we could choose to make the result a polynomial? Is there a number you could substitute for c, give us no remainder? Think about it. Think about the long division. How did we get the remainder? Is there a number we could use for c to get the remainder? Or look at the expression we ended up with, 2x cubed minus 5x squared plus 7x plus c. Well, again, if you can find the c that doesn't give us a remainder, then the quotient would have 0 remainder. Okay, what value would c not give us a remainder? Take a minute to think about that. Okay, now if you haven't got it, that's okay, because you'll understand when I say, well, if c equals negative 10, that's not going to have a remainder. And the remainder, c plus 10, would be 0. And the quotient would be x minus 2. I'm sorry, finding out the multiplication, which is kind of the next step that I'm not going to do. The quotient would just be 2x squared minus x plus 5 plus 0. Because again, c plus 10 over x minus 2 would be negative 10 plus 10 over x minus 2. Conclusion, is that 2x cubed minus 5x squared plus 7x minus 10 equals x minus 2 times 2x squared minus x plus 5. And you can multiply this out and see it. Now, whether you totally understand that or not, this illustrates or gives excuse me a second, I'm not sure all the board is visible. Okay, I think we can understand this. You didn't get to see all this. All we're saying now is if C is negative 10, then that makes your C plus 10 over x minus 2 0, so that your quotient is just 2x squared minus 5x. That's our 2x squared minus x plus 5. If the quotient is 2x squared minus x plus 5, and this term is 0, then our original polynomial, 2x cubed minus 5x squared plus 7x minus 10, has to equal x minus 2 times 2x squared minus x plus 5. This is a big deal. Let's look at what we've got. Okay, again, 2x squared, 2x cubed minus 5x squared plus 7x minus 10 equals x minus 2 times 2x squared minus x plus 5. Now you can multiply this out and verify it. What we've done here is we've factored x minus 2 out of the expression 2x cubed minus 5x squared plus 7x minus 10. So if we want to find the zeros of p of x equals 2x cubed minus 5x squared plus 7x minus 10, we can say that those are the same as the zeros of the quantity x minus 2 times 2x squared minus x plus 5. We want to find the zeros, then we have to solve the equation x minus 2 times 2x squared minus x plus 5 equals 0. How do we solve that equation? We use the zero property of multiplication, and we determine that either x minus 2 equals 0 or 2x squared minus x plus 5 equals 0. X minus 2 equals 0 is easy enough to solve. We add 2 to both sides. So we get x minus 2. What are the solutions of the equation 2x squared minus x plus 5 equals 0? Well, we can use the quadratic formula. We're going to get x equals 1 plus or minus the square root of 1 squared minus 4ac, that would be 40 over 2 times 1. That's 1 plus or minus the square root of negative 39 over 2. But the square root of negative 39 is not a real number. So I'm going to say that the factor 2x squared minus 5 minus x plus 5 yields no zeros. Our conclusion is that original polynomial has only one zero, that's at x equals 2. So if we're drawing a graph of the polynomial, what information do we have? From this, we know that we have a 0 at x equals 2. Let's sketch a vertical line here and label it x equals 2. And I know that this is a point on the graph. We know that we can also easily find the y-intercept. We just let x equal 0. So the expression 2x squared minus 2x cubed minus 5x squared plus 7x minus 10, when x equals 0 is equal to negative 10. So we can draw a horizontal line for y equals negative 10. And we can indicate that point on the y-axis. Now we can use the other things that we know about polynomials. Say that, well, the graph of this function could be one of two things. It could look like this. Actually, one of more than two things, okay? It could be just a kind of a x cubed curve that flattens out somewhere above the x-axis. It could be kind of an x cubed curve that flattens out somewhere below the x-axis. Or it could be an x cubed curve that has wiggles. Okay, and I'm just trying to decide where to put the wiggles, just by constraints of the room I have, the amount of space I have. Maybe it comes up like this, has a peak, then goes down to a valley with the peak below the x-axis. It's entirely possible. Or it could be like that same graph, but situated where the peak and the valley are completely above the x-axis. One thing that happens is, though, that the x-axis is not going to go through more than one point. Okay, I could say a little more about that, but I think I'm saying enough. So here's what we do when we have a polynomial. If we're given the polynomial p of x equals x cubed minus 5x squared plus 7x minus 10, and we don't know to divide by x minus 2, and the value of x makes p of x 0. There are numbers we can try. Numbers, you should have a factor that leading coefficient, and there should be a 2x squared minus 5, 2x cubed minus 5x squared plus 7x minus 10. You should have a number whose numerator is a factor of 2 and denominator is a factor of 10. That's something else, and that's something you're going to have to approach in your pre-calculus class. I'm going to say right now, to make it simple, try x values plus or minus 1 or plus or minus 2. We're not going to try fractional values at this point. Okay? So, p of 1 equals 2 times 1 cubed minus 5 times 1 squared plus 7 times 1 minus 10. Well, that's going to be 2 minus 5 is negative 3, plus 7 is 4, minus 10 is negative 14. Okay? So we're going to try p of negative 1. Now, evaluate that yourself. Stop and work it out. See what p of negative 1 is. Okay, well, p of negative 1, plug in negative 1, we're going to get 2 times negative 1 cubed minus 5 times negative 1 squared plus 7 times negative 1 minus 10, which equals negative 2 plus minus 5 minus 7 minus 10. Well, every one of these is negative, so we don't even have to add them up to know that that's not 0. So we tried x equals negative 1, it didn't work. Try now x equals 2. What do you get if you do p of 2? Okay, hopefully you've paused and done this. But if you do p of 2, you're going to get 0. If you evaluate that correctly, you get 2 times 2 cubed minus 5 times 2 squared plus 7 times 2 minus 10. 2 cubed is 8, 2 times that is 16. 2 squared is 4, minus 5 times 4 is minus 20. 7 times 2 is 14, minus 10. Well, our negatives are negative 20 and negative 10, so we're going to have negative 30. Our positives are 16 and 14, which adds up to 30. And that gives us 0. Okay, so our procedure is going to be, for polynomials, we try reasonable values of x and see if we can find one that gives us 0. that makes the polynomial equal to 0. If it is, we know that well, let me write it out. Since x equals 2 makes p of x 0, we know that x minus 2 is a factor of p of x. Okay, remember, looking at what we already know, that if x minus 2 multiplied by some other polynomial equals our original polynomial, then x minus 2 can be 0, x can be 2, and that will make it 0. So if x minus 2 is a factor, if x minus 2 divides the original polynomial, then x minus 2 times the quotient of that division will equal 0, and x can equal 2. Now that's a lot to digest, but here's the way it looks. This is a factor of p of x, and it follows that x minus 2 divided into p of x gives you no remainder. In other words, x minus 2 divided into 2x cubed minus 5x squared plus 7x minus 10 comes out even. This should yield a quotient. No remainder. Well, saying that this is so. X minus 2 divided into 2x cubed minus 5x squared plus 7x minus 10 gives us 2x squared, and let's make sure I get it right, minus x plus 5. So that x minus 2 times 2x squared minus x plus 5 equals 2x cubed minus 5x squared plus 7x plus 10. Then we can write this like so, set it equal to 0, and do what we've already done, find a 0 of the polynomial and get some idea about its graph. Okay, now that's all we're going to talk about with polynomials in this course. Hopefully you understand the argument here, and it just goes back to if we do this division with some number on the end that we call C, we get this quotient. There's one number, C equals negative 10. So you put a negative 10 on here. That makes this come out even. If C is any other number, then c plus 10 isn't going to be 0, and we're going to have something over x minus 2. If you can find this number, if you're given this polynomial and don't know that 2 is a 0 of the polynomial, then you got to try different numbers. Now there's the rational roots theorem. It gives you numbers to try. If you get a polynomial for some application, it's very unlikely that it's going to factor. So personally, I don't find this a particularly applicable technique in everyday life, but it gives you an idea of the structure of polynomials, and it's kind of worth stretching your brain to understand that. So there we have this idea, and we're going to move on. Yeah, another one. Okay, now we're switching attention to rational functions. If we let r of x equal x minus 3 times x plus 4 over x plus 1, we can expand the numerator we get r of x equals x squared plus x minus 12 over x plus 1. Okay? So my first question is, what are the zeros of r of x? What numbers can we plug into r of x to make it 0? Okay? Well, factored form makes it easy to answer. Any rational function is 0 when the numerator is 0. And just to be complete, I'll say, and the denominator isn't 0. So denominator and the numerator are both 0. That's something you'll get into in the pre-calculus class. Here, I just want to give you the broad outline of how you approach rational functions. Okay, well, the numerator is x minus 3 times x plus 4. I mean, it's also x squared plus x minus 12, but that could be factored into x minus 3 times x plus 4. That x minus 3 times x plus 4 equals 0. Well, that splits into two equations, x minus 3 equals 0, or x plus 4 equals 0. So that x equals 3 or x equals -4 makes r of x 0. This means that we can start a graph of r of x. And out here, let's say x equals 4 here. Yep. Say x equals 3 here, and x equals -4 here. Then we know the graph goes through these 2 points. Okay, now let me ask you, is there a number that makes the denominator 0? Okay, just to be sure, we clarified what the numerator was and what the denominator was, because some people weren't sure of that and maybe got that mixed up a little bit. So there's our terminology, numerator over denominator. And then I immediately got the answer, okay, x equals -1. Well, that's the answer to the question, where's the denominator 0? Okay? And I asked that question, but didn't write it down. So this is the question we always ask. If you're given a rational function, a polynomial divided by a polynomial, if you're given this polynomial, you would factor the numerator. And if the denominator is not just a linear function, you would factor the denominator, if possible. If this is a plus 12 over here, you wouldn't be able to factor the numerator because all the zeros would be complex numbers. It wouldn't give you any zeros. Okay, well, we don't need to worry too much about that right now. For what value is the denominator 0? First of all, the denominator is x plus 1. Denominator 0 if x equals -1. Okay. Well, for reasons that we don't have time to go over, as we're short on time now, we sketch the line x equals -1. And this is going to be a vertical asymptote. From this and a little more, we can figure out how the function behaves. Okay? The other thing we can get is the y-intercept. When r of x equals 0, when x equals 0, I already figured out where r of x equals 0. So we plug in x equals 0 into the equation. Get y equals 0 minus 3 times 0 plus 4 over 0 plus 1 equals -12. So the y-intercept is that y equals -12. Say y equals -12 here. Okay, then there's more. You have to consider the behavior as x goes to infinity or negative infinity. You find that when x goes to negative infinity, the graph is below the x-axis. It actually comes up something like this, and then curves around and approaches the vertical asymptote. Then the graph still approaches the vertical asymptote on the other side, but it flips around, approaches it from below, goes through this point, probably starts to level off, and goes through this point, and then does so. And the graph ends up looking like this. Okay? Now we don't have time to work it out. But what if we had r of x equal x squared plus 5x minus 1 over x squared plus 8x minus 15? Numerator is 0. X squared plus 5x minus 1 factors into x plus 6 times x minus 1. You got x equals 6 or x equals 1. Negative 6 or x equals 1. So if I draw the x equals 1 line here, the x equals negative 6 line here, I have 2 points on the graph. The denominator 0 means x squared plus 8x plus 15 equals 0. That factors into x plus 3 times x plus 5 equals 0, so that x equals, well, x plus 3 equals 0 or x plus 5 equals 0, so that x equals negative 3, x equals negative 5. That gives us 2 vertical asymptotes. At x equals negative 3, well, that would be about here, or x equals negative 5. The y-intercept occurs when x equals 0, and that happens to be at, if x is 0, everything with an x on it is 0. You end up with negative 1 over 15. So you have this y-intercept. Then you figure out how to make the graph go through all 3 of these points and have vertical asymptotes. Turns out the graph is going to look something like this. I'm kind of stuck. Got something wrong. Oh yeah, this should be negative 1/15. I labeled it y equals negative 1/15. So this point is actually below the x-axis. So now oops, it's not an asymptote. Now I've got it kind of messed up. The graph comes through here, then goes through here, and comes out like this. Now there's a lot more to it. It looks kind of mysterious, but these graphs look kind of weird. You analyze them by first thing with a numerator 0, with a denominator 0. With a numerator 0, you typically have zeros. With the denominator 0, you typically have vertical asymptotes. Vertical asymptotes act like this. They act like the 1 over x function or the 1 over x squared function acts near the y-axis. Okay, well, we're over time, and I do need to clear some boards to get ready for my next class. There's a lot more to it, but we'll talk about it when we come back.